Hello everybody and welcome to today's lesson on surface area and lateral area. Today our objective is we will be able to use formulas for lateral and surface area of three-dimensional objects to solve real-world problems. So let's briefly review the key concepts first. Area is the space covered in two dimensions. And because it's two dimensions, we use square units or units squared for areas. When we talk about areas, I want you to think of covering something, for example, with paint, color, or tiles covering the floor, and it is something flat. It's two-dimensional. Surface area is the sum of the areas of all the faces of a solid object. The surface area is two-dimensional. The solid object itself is three-dimensional, however. And since it's another type of area, again, we're going to use units squared for surface area. When we talk about surface area, I want you to think of covering all the sides and the top and the bottom of an object. For example, wrapping a present. And then we have the lateral area. The lateral area is the sum of the area of the lateral faces of a solid that has a base. And again, the solid is three-dimensional, but the lateral area is two-dimensional. And when we talk about lateral faces, what we mean is we mean the sides of that object. So I want you to think of covering only the sides. Like, for example, the label on a can. We're not covering the base, and we are not covering the top or the bottom. Lateral means just covering the sides. Let's go to an example and try it out right away. A square pyramid that is 4 feet tall has a base that measures 6 feet long. How many square feet of paint are needed to cover this entire pyramid? Since we've been asked about square feet in the question, we are talking about an area. And since we want the entire area, we know that it's got to be the surface area. So we need to go to our formula sheet and find the formula for the surface area of a pyramid. And here it is. I'll write it down here on the left. The surface area is equal to 1/2 LP plus capital B. First of all, we need to know what all these letters mean. L is this line here in our pyramid, and it's called slant height. So it's the height of a slanted surface. And how do we find this height? Notice that the slant height together with the height h and this line form a right triangle. Let me just draw this right triangle right here. We know that the height of the pyramid is 4 feet, and we know that the base measures 6 feet. The length of the base is 6 feet. That means that half of that is 3 feet. And now we have two sides of a right triangle, and we can use these to find a third side, of course, with the Pythagorean Theorem. C squared is equal to 3 squared plus 4 squared. C squared is equal to 9 plus 16. Some of you may already be one step ahead. I'll show you how. C squared is 25. Taking the square root of C squared, C is 5. That's the length of our hypotenuse here, which is the slant height. And this is, of course, the Pythagorean triple, 3, 4, 5. Now we know our slant height, and we can start filling things into our formula for the surface area. The surface area is equal to 1/2 times the slant height, which is 5. Next we need P, and P stands for the perimeter of the base. And the perimeter is, of course, when we add all the sides around the base. We know that the base measures 6 feet by 6 feet. It's a square, so all sides have the same length. That means we just add 6 plus 6 plus 6 plus 6, 4 sides with the length of 6, and that will give us 24. And that is 24. And last but not least, we need our capital B. And remember, capital B is the area of the base. The base is a square, we've been told that, and we know that the side length is 6. The area of the base we get by multiplying length times width. Or in the case of a square, it's just multiplying the side by itself, and that will give us 36. And now we have all we need to calculate our surface area. The surface area of our pyramid is 1/2 times 5 times 24. So 1/2 times 24 is 12. Getting rid of our fraction. 5 times 12 is 60. Plus 36 is 96. And we are talking about square feet. That's already in our problem. Areas are always square units. Squared feet. And here is our answer. In part B of the problem, we are asked how many square feet of paint are needed to cover the pyramid, but not the floor. Everything but the floor. That means just the sides. And we know what that means for our formulas. We are now talking about the lateral area. Formula for the lateral area is on a formula sheet as well. The lateral area is 1/2 times L times P. We have already found these parts in the previous part of the problem, so let's just plug them in. 1/2 times 5 times 24. 1/2 times 24 is 12 times 5 is 60. The lateral area is 60, and again, square feet is the unit. And we could also have said the lateral area is the surface area minus the base, because the base is not part of the lateral area. Excellent. Well done, you guys, and let's move on to our next example. In example 2, we have to find the surface area of this ice cream cone. And the ice cream cone is called a cone, but it's actually more than just a cone. If we look at it, we have our scoop of ice cream on the top, and that as a hemisphere. Remember, hemisphere is half of a sphere. And we have the bottom part, which is the actual cone. Let's start with our hemisphere. We have the formula for the surface area of a sphere on our formula sheet. We don't want an entire sphere, we want a hemisphere, so all we need to do is we take 1/2 of the surface area of the sphere. 1/2 times 4 times pi times r squared. Now what is r? Look at our picture, we see that 8 centimeters is the diameter of our sphere. That means that the radius is half of that. R is 4. Plug that into a formula, 4 squared. Let's go ahead and calculate this. 1/2 times 4 is 2. 2 times 4 squared, that's 16. That gives us 32. And we're not going to punch in the pi into the calculator just yet. We always do that at the very end only. Maybe something is gonna simplify away. So 32 pi is the surface area of our hemisphere. Next, we need to measure the area of our cone. And when we do that, we need to consider that it's not the surface area we're looking for the cone, because the base of our cone, which is this area in here, is actually covered by the hemisphere. This part is not towards the outside, so what we're really looking for a cone is the lateral area. And there is the formula for us right here. The lateral area of a cone is equal to pi times r times L, and L again is the slant height. To find our slant height, we are going to draw a right triangle again. The height of our cone is given to us with 12 centimeters. The radius is 4, and so our slant height L squared would be 12 squared plus 4 squared. So that's 144 plus 16. L squared is 160. That means that L is the square root of 160. 160 we can split up nicely. There's a 16 in here. 16 and 10. Square root of 16 is 4. So we're talking about 4 times the square root of 10. That's our slant height. Now let's put that into our formula for the lateral area. We got pi times r, which is 4, times 4 times the square root of 16. And we're going to keep that square root of 16 for now. We got 4 times 4, that's 16. So we got 16 pi square root of 16. That is our lateral area. So then our total surface area is equal to 32 pi plus 16 pi times the square root of 16. And now you can go ahead and punch it into the calculator, and you're going to get, that's approximately 259.5. What is our unit? We have been dealing with centimeters, and we have a surface area. Areas are always squared, so centimeters squared. There's our answer. And now let's move to our last example. You are wrapping a present in the shape of a triangular prism as shown. Find the minimum amount of wrapping paper needed to cover it entirely. So we're wrapping a present. We talked about wrapping presents before. That means we're talking about area. Also cover means we're talking about area. And since we're supposed to cover it entirely, that means it's the surface area, not just the lateral area. The surface area of a triangular prism is given to us on the formula sheet. Here it is. Surface area is equal to HP plus 2 capital B. H is the height of our prism. Now, what is the height? We have several side lengths given here. Be sure to remember that the height is the side that connects the two bases. It's the side that goes from one of the triangles to the other. That's our height. And in our example, that's the 10 centimeters. That's the side that connects the two bases. This is our height. So the surface area is equal to 10 times, next we need the perimeter, and the perimeter is the perimeter of our triangle. Remember, for the perimeter of a triangle, we need to add up all the sides. We have two sides given, the 16 and the 12 centimeters, but we do need the third side. And yet again, we have a right triangle. So always make that drawing. That really helps you to organize your thoughts. You have a right triangle. One leg is 16 centimeters long, the other leg 12 centimeters long, and we do not know the length of the hypotenuse. I'll call it C, because the Pythagorean theorem will help us here yet again. C squared is equal to A squared plus B squared. C squared is equal to 16 squared plus 12 squared. That means C squared is equal to 256 plus 144, which is 400. And therefore the square root of 400 is 20. That means that C is equal to 20. And if you already noticed that 12 divided by 4 is 3, 16 divided by 4 is 4, and then 20 divided by 4 is equal to 5. And yet again, we have our 3, 4, 5 Pythagorean triple. If we see that, we can go right ahead and use it. If not, don't worry about it. Just use the Pythagorean theorem. You'll get the answer too. Now we're ready to find the perimeter. P of our triangle is equal to 12 plus 16 plus 20, and that is 48. So 48 goes into our formula for the surface area. And last but not least, we need the area of the base. And that is really just the area of the triangle. We already found the perimeter. Now we're going to find the area of the triangle, and we have the formula for it right here. Also, the area of a triangle is 1/2 the base, lowercase base, which is the length of the base, times h. That's equal to 1/2 times 12 centimeters is the base of our triangle, and 16 is the height. 1/2 times 12 is 6, and 6 times 16 is 96. And we need 2 times the 96. And now we're ready to calculate our surface area. Surface area of our triangular prism is 672 centimeters squared. Circle your answer, and we're done. So, you guys, to summarize, with these last 3 examples, you have seen that very often in these types of problems, we need to calculate several things and then put them back together. And that is what you need to pay attention to. Sometimes we need some side lengths or other things. Find them first. We have all the tools. We have all the formulas that we need on our formula sheet. So do it step by step, and you're going to be golden. Alright, you guys, that's it for today, and I will see you in class.